Hello again. This video is about increasing and decreasing functions, and the goal of it is to determine if a critical point is a local max or a local min, and to determine the intervals in which our function is increasing and decreasing. So the first two things I have here are pretty straightforward. Theorem 2 says that if you have a differentiable function on an open interval, if the derivative, what this says right here, if the derivative is positive on this interval, some interval a, b, then my function is increasing. So really all that means is if your slope is positive, that means your function is growing. The second one here says if your slope is negative, then your function is decreasing. And then down here we have some pictures of to show what we just read in Theorem 2. Again, this graphical insight shows that if the derivative is positive, so these pink lines are the derivatives, and they all have a positive slope. And as you can see, the function here is increasing. And then the second bullet point here, if the derivative is negative, like in these lines over here, these pink lines have a negative slope. They're tangent to the graph, and the graph is decreasing. So now what we're going to do is going to test critical points. And Theorem 3 just says if my first derivative changes from positive to negative, that means over here if my slopes are positive and then they turn negative, that usually happens at a critical point, and that means that we have a local max. Whereas if you rise and then fall, you created a local maximum. The second bullet point over here says if your slope or your derivative changes from negative to positive, then you have a local minimum. So over here, if we go from negative, so we have negative slopes, so our function's decreasing, and then all of a sudden we are at a point where the slopes are positives or our function's increasing, we have created a local minimum. So I just did the work over here on the side. We started off with this function f of x equals x to the third minus 27x minus 20. First thing I did was find the critical points. So the first derivative gives me 3x squared minus 27. Set it equal to 0. So I factored out a 3 first, and we're going to get x equals 3 and x equals negative 3. We also find critical points by finding where our derivative is undefined, but this derivative is never undefined because there's not a denominator. So the next thing we're going to do now is put in our critical points on a number line. So I'm going to put negative 3 and positive 3 on a number line. This is where we're going to have our possible maxes and mins, because those are our critical points. So what we will do here is plug a number from each section into the derivative to find if the slope is negative or positive. So we're going to pick a point over here in this section. So I just picked negative 4. You can pick any point you want. So if I plug negative 4 into this derivative, I will get 16 minus 9 times 3, which is positive. And that's all I really care about, if it's positive or negative. Then I found a point in this section, which is 0. I plug 0 into the derivative, and I got a negative answer. And then I picked something from this section here. I picked 4, and if I plug 4 into this derivative, I will get a positive number. So basically what we have is, let me get my screen going here. Over here, we're going to have, this is positive, whoops. This will be positive, this part is negative, and this part is positive. And what I have done here is figured out the sign of f prime at x. So my original graph now is going to be increasing on this interval, decreasing on this interval, and increasing on this interval. So if you can imagine now, if you go back to if we are going increasing, first derivative is positive, and then decreasing, first derivative is negative, at x equals -3, we have a local maximum. So, like same over here. If I go from negative, which means I'm decreasing, to positive, which means I'm increasing, I'm going to have a local min. So we now know that x equals 3 is a local min, and we know that x equals -3 is a local max. If I look at these pictures over here on the side, this is the picture of my actual f of x. And you'll see it is increasing, decreasing, and increasing, just like our chart over here said. And if you graph the derivative, you'll see that it's positive, which means it's above the x-axis. Then the derivative is negative, which means it's below the x-axis. And then the derivative is positive again, which means it goes up above the x-axis. Okay, here's another example. We're going to look at g of x, which is given by this function right here. And I want to know what intervals g is increasing and decreasing. I also want to know where my local maxes and local mins are at. So the first step in all of these kind of problems is finding the critical points. So I did that. I took the first derivative, factored out of 3, and then factored the quadratic. So I know the critical points happen when x is 3 and when x is -1. Now, we're going to, step 2, let's see if I can get this showing correctly here. In step 2, we're going to put the critical points on a number line. So, -1 is a 0, or a critical point, and 3 is a critical point. So I put this here again just to make sure we had it, but if my first derivative goes from positive to negative, I'll have a local max. If it goes from negative to positive, I'll have a local min. So once we get this whole thing set up here, we're going to take and plug a point from each interval into the derivative. So if I, in this interval right here, I picked -2. So I plugged -2 up here. And if I plug -2 up here, I will get a positive number, which I have shown right here. Then I picked a number from this interval. I picked 0, plugged it into my derivative. Again, if you want to stop this, you can, but if I plug 0 into the derivative, not the function, I will get a negative number. And then I picked from this interval, I picked 4. So if I plug 4 into the derivative, I get a positive number. So now we are going to just fill out our sign chart. And my first derivative goes from positive to negative to positive, which means my function is increasing, decreasing, increasing. So I know the intervals on which I'm increasing is going to be -infinity to -1, together with 3 to infinity, and I'm decreasing between -1 and 3. I also know that this point right here is going to be a maximum, and this point right here is going to be a minimum. So at x equals 3, what do I have? I have a local min. And at x equals -1, I have a local max. Okay, I know this video is over 6.5 minutes, but we have one more example we have to do. So the example 3, we're going to just look at f of x equals x to the 5th, and we want to know where we're increasing and decreasing, and we want to know where we have local maxes and local mins. So the first step again is to take the derivative, set it equal to 0 to find the critical point. So we have one critical point. We're going to put that critical point on our number line, and then we are going to test. So I picked -1 from this side and +1 from this side. And when I plugged it in, which my notation's off here, so let me see if I can fix this real quick. I plugged it into the derivative on both of those, and they both turned out to be positive, which tells me that I don't know why I have these backwards. Let me fix this real quick. Let's call this f prime, and let's just call this f. So my derivative in both cases is positive on both intervals, and that means that my function is increasing the whole time. So this function always increases. There is no local max or local min. Just because we had a critical point doesn't mean we will have a local max or local min. The critical points are just possible local mins and local maxes. So hopefully you guys kind of get the pattern to this. Step 1 is always going to be finding your critical points. And then you're going to put them on a number line. And then you're going to test the intervals. And then from then, well, I can't spell intervals. Let's try that again. Intervals. Test your intervals using the first derivative, and then you'll know where you're increasing, decreasing, and where your maxes and mins are.